So good morning students, welcome back. Okay, today we'll start the new lesson. Lesson number 4, magnetic effect of electric current. Magnetic effect of electric current. And our first topic is Oersted experiment. Okay, what is Oersted experiment? Okay, now I'm going to start. Look at students, see. Oersted made a circuit. Okay, what he explained, very first Oersted explained by his experiment that whenever we flow current in a wire, that generate magnetic field around it. Okay, whenever we flow current in the wire, it generate magnetic field around it, and such effect is called magnetic effect of electric current. Okay, so that we are going to prove with the help of an experiment. So let's start the experiment, students. Look students, we'll start the Oersted experiment. See, he made a circuit in which he connected a cell switch with a conductor wire, and he put a magnetic needle, okay, just below the circuit. Now students, see, this is the first condition what he did in his experiment. Look at, when the switch K is on, okay, current flows from positive terminals to negative terminals. Okay, see, the direction of current is from A to B. In other words, we can say, okay, actually this is the direction, north, south, east or west. But when we make the direction of current along this wire, north, south, east and west. So look at students, see the direction of current. Current is moving from positive terminals to negative, A to B. This is said to be south to north. Okay, it means in first condition, the direction of current is from south to north. What he observed, when the direction of current is from A to B, from south to north, in that condition, the north pole of the magnetic needle deflected in the direction of west. Look at students, in the direction of west, it means in the direction of current. That was the beginning position of needle. When the current flows from south to north, this needle deflected like this. It means the north pole of the magnetic needle deflect in the direction of current. It means in which direction? Towards the direction of west. Later on we'll discuss also how can we find the direction of magnetic field. There are lots of law, Snow rule, Ampere swing rule, okay, right hand thumb rule, Fleming left hand rule. So when the direction of current is from south to north, magnetic field is always axis in west. Later on we'll discuss. That's why when the current flows from south to north, the north pole of needle, okay, deflected in the direction of west, in the direction of current. Okay, that is the first condition. What he did in second condition? In second condition, he changed the polarity. Now, this time current is moving from B to A. In other words, we can say B to A means what? North to south. In second condition, the current is moving from north to south. So, look at students. That was the beginning condition of that needle before switch on the current. When we switch on, when the current flows, this magnetic needle deflect like this. That is the beginning condition, initial condition. It will deflect like this. It means south pole of the needle deflect in the direction of west. Either we can say north pole deflected in the direction of east. Okay. So in that condition, when the direction of current from B to A, we can say from north to south, in that condition, south pole deflected in the direction of current. In first case, north pole deflected in the direction of current. In second case, south pole deflected in the direction of current. And in third condition, when the switch is off, when there is no current in that circuit, in that condition, that magnetic needle does not shows any deflection. It does not shows any deflection. It remains in the state of rest. Okay, it means what he observed. When we flow current, okay, needle deflect in the direction of current. When we flow current, needle deflect in the direction of current. Okay, when there is no current, it does not show any deflection. It means one thing that we know, magnet always attracts towards magnetic element or magnetic field. Without magnetic field, it will not show any deflection. Here it is also not showing any deflection without current. It means he got a point that suppose that is a conductor wire. Whenever you flow current in a conductor wire, it produces magnetic field around it. It may produce magnetic field around it according to that. And when we flow current, they produce magnetic field around the wire, and this magnetic field, due to this magnetic field, magnetic needle attract towards that magnet. That's why it's showing deflection in both the cases. And when there is no current, there will be no magnetic field. That's why it does not show any deflection. So we got a point. Whenever we flow current in a wire, it generates magnetic field around it. Such effect is called magnetic effect of electric current, and this is the Oersted observation, Oersted experiment. So simple, how can we generate magnetic field? Simple, when we flow current in a wire, it produces magnetic field around it.